Hello, my name is Abby Sicklesteel and my partner for this presentation is Shin, and today we will be talking about design of experiments.
Design of experiments is used to increase productivity and improving quality by determining if and how a factor affects the response. The old methods included just a trial and error method, and it was very costly in both money and time. Now, design of experiments is more of a guided trial and error method. To conduct a design of experiments, you need factors, levels of those factors, and their responses. For example, you're trying to make orange chicken. Some factors that go into the recipe are orange juice and flour for the breading. The levels would be the amounts of each factor, high, medium, and low. The responses would be the taste. You could conduct a factorial design and do high, medium, and low amounts of each factor, and test to see which results use the maximum desirability from consumers.
For our example, we will be doing the popcorn example. We have done this in class before. The goal is to find the best way to microwave a bag of popcorn. Our factors for this experiment are how long to cook the popcorn, what level of power to use on the microwave oven, and which brand of popcorn to use. The levels for the factors for this experiment are, respectively, between 3 and 5 minutes, between settings 5 and 10, and top secret or Wilbur. The responses are the number of pop kernels and the total number of kernels in the bag. Now we will be doing a live demonstration. To conduct the design of experiments, we will click on DOE, then Custom Design. First, we will rename the Y response to number popped and leave the goal of this response to maximize. We will click Add Responses and choose None from the menu that appears and rename it as Total Kernels. Next, we will add our factors by clicking Add Factor and then Categorical and then To Level. We will change the name to Brand. Then we will do the same for time and power, but these responses will be continuous instead. The values for brand are either top secret or Wilbur. The values for time are 3 and 5, and for power they are 5 and 10. This means it will pick numbers from that range of values for the design of experiments. Next, we will define the factor constraints by opening the Constraints panel. We will click Add Constraint button twice and change it so that the time plus power is less than 13, but more than 10. Next, we will add interaction times. We will click Interactions and then click Second. Next, we will click the Powers button and select Second to add quadratic effects of the continuous factors, power and time. Next, we will determine the number of runs. We will use the jump default number of runs, which is 16. We will click Make Design to continue. Then we click Make Table, and now we have our data table to conduct our experiment. We would actually go out and conduct these experiments and put into jump the number of kernels popped and the total number of kernels when using those particular settings. But now let's open the file where this model was used and they conducted the experiment and got the results. We will go to the script labeled Model and run the script. We will change the personality to generalized linear model, the distribution to binomial, and link function to logit, and click Run. We will scroll down to Profilers and click Profiler. We can move the red lines around and the red text indicates what point the red lines are at. Now we will select desirability functions and then maximize desirability to get the optimal settings to have the most popcorn popped. To maximize desirability, you should use Top Secret, microwave it for 5 minutes on the power setting 8.
When creating the design, it means that you are coming up with possible factors that affect your process. When performing the experiments, you're trying to see which factors, if any, actually affect the process.
The underlying model that is used depends on what kind of experiment you are running. In this class, we will mainly be dealing with linear and quadratic models.
You perform design of experiments when you want to determine the relationship between factors affecting a process and the outputs from that process. In simpler terms, you use design of experiments to determine the cause and effect relationship between factors and outputs of a process. According to the Design of Experiments guide, you perform a response surface method design of experiments when you are modeling a curved quadratic surface to continuous factors. It can pinpoint a minimum and maximum response if one exists inside the factor region. 3 distinct values for each factor are necessary to fit a quadratic function, so that the standard 2-level designs cannot fit curved surfaces.
You profile the response surface method using the prediction profiler or the contour profiler. The prediction profiler is used to find the settings that produce the best response target, and it is an interactive way to change variables and look at the effects on the predicted response. In the picture is an example from the data set bounce data. The first 3 plots display prediction traces for each x variable, which is the predicted response as one variable is changed, while the others are held constant at the current values. The bottom three plots are the plots for each factor showing its desirability trace. The contour profiler is used when you want to view the response surfaces graphically, especially when there are multiple responses. You can enter the low and high limit values to shade the unacceptable regions in the contour plot. Thank you for watching.